Welcome. So there is no real number solution to the equation x squared equals -1. Why? The simple quadratic equation, the square root of x squared, equals positive and negative square root of -1. So if we were solving a quadratic by taking a square root, right? Quadratics have two solutions, right? Because they're squared. So we have to have the positive and the negative square root. Right? So if we take the positive and negative square root of -1, what do we get? Well, I'm not sure. Right? If I square 1, I get 1. If I square -1, I get 1. So x squared equals -1 has no real number solution, since there's no real number which when squared gives -1. By introducing just one new number, which we'll call I, we'll generate a set of numbers called the complex numbers, which are extremely important in mathematics and engineering. Let's learn more about these complex numbers. In real life, complex numbers are used by engineers and physicists to measure electrical currents, to analyze stresses in structures such as bridges and buildings, and to study the flow of liquids. Engineers who design speakers use complex numbers. Engineers who design and test the strength of bridges use complex numbers. Scientists who do experiments on ways to make energy using fuel cells, batteries, and solar cells use complex numbers. Complex numbers are also used for generating fractals, which are geometric objects created by making a repeating pattern. Right? So no matter how hard you look, you just keep seeing the same pattern over and over and over again. Right? So you see a pattern, you look a little closer, and the pattern's made up of the same pattern. And you look a little closer, and the pattern that made up the pattern is made up the same pattern. So just on and on and on. And fractals are very interesting. I just have like two examples here, and they're I don't know if they're filming as well as they could, but if you look online, you can see even more fractals. So electrical current measurements are important to people who want to use electricity in creative ways. If you want to redesign your stereo to make it play the bass louder, or to add components like a turntable, you might want to make some electrical measurements to make sure the components are compatible with each other. Electrical current is used as direct current or alternating current. When working with AC, complex numbers are needed. Right, so let's take a look at complex numbers. Right, so basic concepts of complex numbers. The set of real numbers is a subset of the overall set of complex numbers. In order to extend the set of real numbers to include even roots of negative numbers, such as the square root of -1, the number I is defined to have the following property. I squared equals -1. Right? So when we square I, we get -1. And therefore, if we take the square root of -1, we get I. So from this definition, we have the imaginary unit, I, equal to the square root of -1. Now, imaginary unit makes it sound like something not very important, right? Like it's make-believe. But I is not make-believe, and it's very important. It just has kind of an interesting name. So numbers in the form a plus bi, where a and b are real numbers, are called complex numbers. In the complex number a plus bi, a is the real part, and b is the imaginary part. Right, so let's start off with the numbers that we're familiar with as we work our way up the complex number system. Right, and we can start with integers. Right, so integers are whole numbers and negative numbers, like 5 and -7 and 0 and 2. Non-integer numbers, such as 3/4, 1.9, 7.33 repeating, 2/3, 10.75, right? Together with our whole numbers and our negative numbers make up the rational numbers. So rational numbers are any number that can be written as a fraction. All right, so if you can write it as a fraction, it's a rational number. We can write whole numbers as fractions. We can write negative numbers. Of course, fractions already are fractions, and decimals that terminate or repeat can be written as fractions. Right? So what numbers can't be written as fractions? Well, numbers like the square root of 2, the square root of 17, and pi. Those are irrational numbers because they never terminate and they never end. Right? Decimals that never terminate never end. The rational numbers and the irrational numbers together make up the real numbers, with a plus bi where b is 0. So there's no imaginary part because they're real numbers. We also have imaginary numbers, a plus bi, where a is 0, so there's no real part. So the real numbers, together with the imaginary numbers, make up the complex numbers with a plus bi. So we can have a real part and an imaginary part. Let's look a little bit more at complex numbers. All right, so a complex number, z, that's the symbol for complex number. R is a symbol for real number, is a number of the form a plus bi, where I is equal to the square root of -1. So a complex number has two parts, a real part a and an imaginary part b. So a is called the real part of z, and b is called the imaginary part of z. If b equals 0, then z is a real number, right? So I'd like you to put this in your notes. Right, so if I have the number 7 plus 0b, oops, 0i. I'm thinking of b being 0, and then I wrote 0, b. All right, I wrote 0 instead of b instead of I. All right, so here I have 7 plus 0i. All right, so this would be a real number because there's no imaginary part. All right, so if a is 0 and b is not 0, then z is called a pure imaginary number. So for instance, 0 plus 7i, that would be an imaginary number. If both a and b are not 0, so for instance, 5 minus 2i, we have a complex number. Right, so real numbers and imaginary numbers are part of the set of complex numbers. Right? But here we have both parts. We have the real part and the imaginary part. So this is the real part, and this is the imaginary part. Right, so the standard form of a complex number is a plus bi, where a and b are real numbers. Right? So make sure you know, and then we'll put this in your notes, standard form, right, of a complex number is a plus bi. All right, so we have the real part first, then we have the imaginary. And of course, if we have no imaginary part, we're not going to write 0i. There's no need to do that. And if we don't have a real part, we don't need to include 0. We can just put the imaginary part in. Let's look at one more thing with our imaginary numbers. Let's raise I to some powers here. All right, so we know that I is the square root of -1. Okay. Well, what if I were to square the square root of -1? In other words, we want I squared. All right, so the square and the square root cancel, so this would be -1. What if we cube it? Right, so we have the square root of -1 cubed. Well, that would be the same as the square root of -1, that looks weird, squared, my poor radical there, times the square root of -1. And we already learned that the square root of -1 squared would just be -1, because the square and square root would cancel. And the square root of -1, well, that's I. So we have -I, because there's no reason to write the 1 there. All right, what if we raise it to the 4th power? Right, so we have the square root of -1 to the 4th. Well, that would be the same as the square root of -1 squared times the square root of -1 squared. And we've already learned that the square root of -1 squared is -1, right? Because the square and square root cancel. So we have -1 times -1, which is +1. Right? So let's look at our progression here. So we have I, we have -1, we have -I, we have 1. Wonder what will be next. All right, so I to the 5th, that would be the square root of negative 1 raised to the 5th power. That would be the same as the square root of negative 1 to the 4th power times the square root of negative 1. So negative 1, the square root of negative 1 to the 4th power, we just found out, is 1. And the square root of negative 1, well, that's I. So we get I. Gee, I wonder what will be next. All right, so I to the 6th. Right? So that would be the same as, well, I could take I cubed, right, times I cubed. Or I could take I to the 4th times I squared. Let's do that one. So the square root of, so I to the 6 is the same as the square root of I, or excuse me, the square root of negative 1 to the 6th power, because I is just 1. Or I, excuse me, I is just the square root of negative 1. All right, so this is the same as the square root of negative 1 to the 4th times the square root of negative 1 squared. Right? That would be the same as the square root of negative 1 to the 6th. Right? Because when we multiply, like bases raised to a power, we add the exponents. Well, the square root of negative 1 to the 4th, we learned, was 1. And the square root of negative 1 squared, the square and square root would cancel, and so that would be negative 1. So now we have negative 1. So now we have I, negative 1, negative I, 1, I, negative 1. What do you think the next one's going to be? All right, so I to the 7th, well, that would just be the same as the square root of negative 1 to the 7th, which is the same as the square root of negative 1 to the 6th, times the square root of negative 1, right? That would be 7. So the square root of negative 1 to the 6th, we learned, was negative 1. The square root of negative 1 is I. So now we have negative I. So we have I, 1, negative I, 1. Excuse me, I, negative 1, negative I, 1, I, negative 1, negative I. What do you think the last one I'm going to do is going to be? Can you guess? All right, so let's take, for the square root of negative 1 to the 8th, let's do the square root of negative 1 to the 4th times the square root of negative 1 to the 4th. Well, we learned that the square root of negative 1 to the 4th, well, that was just 1. So we have 1 times 1, which is 1. And by the way, if you keep doing this out, you're going to have the same pattern. So I to the 9th would be I, and I to the 10th would be negative 1, and I to the 11th would be negative I, and I to the 12th would be 1, and so forth and so on forever. Right? So when you raise I to a power, you just keep getting these same answers over and over again in the same sequence. Right? And so it always goes I, then negative 1, then negative I, then 1. So I hope you enjoyed learning a little bit about complex numbers. Now we're going to work with some complex numbers in the next part of this lesson. All right, bye for now.